Great. Thank you for joining, folks. Let me get the next slide. Welcome to today's Tech Talk about get operational insights quickly with natural language on the Splunk platform. Very excited to be talking about this today. Thank you all for joining. I see the attendees counts is growing, so maybe a few more seconds. All right, let's jump into this. Let's start with introductions. My name is Mohit Verma. I'm a principal product manager in the Splunk AI team. I'm the product lead for AI Assistant for SPL, among other initiatives involving AI in Splunk Platform. Jeff?
Hey guys, Jeff Wiedemann here, longtime Splunker, coming up on my 10-year anniversary. And over the last couple of years, I've been focusing full-time on AI as the director of technical marketing, focused on all things AI at Splunk. So happy to be here.
Thanks, Jeff. And to balance Jeff's experience, I joined Splunk in January, so 7 months into my tenure. All right, folks, this is today's agenda. We're going to talk about the problem statement that we're trying to solve, which is what are these obstacles that are in the way of you getting insights from the machine data that you store in Splunk. We'll talk about the intelligence solutions that we are building, including the AI Assistant for SPL. And we want to talk about what's new in this AI Assistant since you probably last heard about it. We've been building and adding a lot of features, so we want to share that with you. And then I know this is a technical audience. We'll leave a lot of time in this talk for Jeff to walk through the technical deep dive of this assistant, including the quality and accuracy. And I highly recommend you stay until the end because we have a major surprise for you towards the end. So really looking forward to popping the bubble on that at the end. And we'll leave some time for Q&A at the end. We'll also try to answer some questions in the chat as they come along. Great. So let's jump right into this. You're all technical Splunk audience. I probably don't have to explain this to you, but Splunk really is useful in unlocking value from your machine data. And there's so many scenarios around observability and security that you use Splunk for, and we're very happy that you do that. One of the challenges, though, is all of these powerful actions, these use cases require deep knowledge of SPL, and SPL is powerful. But learning SPL takes a long time, and the expertise that someone has in SPL is very highly correlated with the value that they can realize from it and how quickly they can realize that value. So we had realized this a while ago, and so we wanted to build a solution for you guys for that. In addition to the time it takes to become Splunk experts, there are additional trends happening in the industry that further exacerbate that problem. The first one is that gone are the days when there was a small team of Splunk users who were responsible for finding the insights and the data. As I talk to more and more customers, I hear that everyone in the organization is now expected to unlock insights from the data and be able to do that in Splunk. So challenge number one. Challenge number two, domain knowledge is quite large, and then experts who have this knowledge move around very frequently, and oftentimes the knowledge is in their heads and it goes away when they leave the organizations. Challenge number two. And challenge number three is the data keeps growing in all of these three dimensions, the volume, velocity, and variety, and just further exacerbates all of those problems that we talked about earlier. So what is every executive saying these days? Every time there is a challenge, someone at the top will ask, hey, how are we using AI to solve these challenges? How are we using AI to become more productive and efficient? And so we believe that we have a great answer for that. So Splunk AI Assistant for SPL, for those who don't know, is a generative AI-powered assistant. It can help you be more productive in doing your search and investigations in Splunk. We'll talk about some of the skills. It has been generally available for Splunk Cloud customers. And I'm very happy to announce that as of yesterday, it's also generally available for Splunk Enterprise customers. Uh, Really excited about that. Looking forward to all of our new customers being able to use the power of AI. So what does this AI assistant do? As I talked earlier, this learning curve in SPL is pretty steep, and the value that you can get from Splunk is highly correlated with that learning curve. And at the top of that learning curve, you see who we call Splunk ninjas. These are experts who know exactly how to get all the value from Splunk, how to write all those complicated SPL searches, how to make all these, write these applications on top of Splunk. And it just takes a while. And how we position AI assistant for SPL is something that sort of uh, makes this learning curve a little less steep, helps these new users make their journey towards the right, and be, if not as efficient, but somewhat closer to these Splunk ninjas as much as possible. And the features that we'll talk about in this talk today are basically the way we think about adding new capabilities into the AI assistant. All of those things are around how do we get these new users be closer to those Splunk ninjas who we love and admire.
And Mohit, if I may just add in really quick, there's probably a lot of people on this call who identify themselves as those Splunk experts and those Splunk ninjas. And so you might be asking yourself, why would I use this tool, or how does this tool benefit me? And this is really where I want you to kind of think about, one of the things we hear often is that the experts in our customers' environments are having to answer questions. They're actively building SPL queries. They're actively, explaining SPL queries, or they're building dashboards. If you identify as one of those experts and you believe, hey, I don't necessarily know that I need to use that. Think about making sure that you expose this technology to newer users as they're starting at the beginning of their Splunk journey, right? And then also identifying, hey, maybe there's a larger group of people where Splunk was, maybe a little too difficult to use and wasn't accessible to them, where now they can start using it with the help of this assistant. So knowing that a large part of our audience may identify themselves as ninjas and experts, I think that's really one way we want you to think about how to position this in your organization.
I think that's a great call out, Jeff. So what does this AI assistant do for you today? As Jeff mentioned, you can use Write SPL to translate your intent, the intent of your investigation, the intent of your search, type it in a natural language, and it will convert it into an SPL search. You can give an existing SPL search. Say you're new to the team, some of the expert users in your team gave you a bunch of documentation that contain a lot of long SPL searches, and you don't know what they're doing. You can paste those searches into AI Assistant, and it'll give you a very nice, easy to understand explanation. As I mentioned earlier, I'm pretty new to Splunk. I joined 7 months ago, so I am one of those new users in Splunk. And so I've been using AI Assistant myself to basically use these skills. So if I need to look at the telemetry for my products, I use WriteSPL to generate those searches. I copy the dashboard queries and ask the AI assistant to explain them to me. And on top of that, if you're, let's say, an admin, or if you're a power user and you want to know how to do something in Splunk, hey, how do I enable two-factor authentication, or how does this complex MLTK command work? You can ask these questions, and then AI assistant can answer them for you. What truly differentiates some of these capabilities from using a public AI tool, say a ChatGPT, is that those public AI tools don't have access to your Splunk environment or the metadata around it. And I don't think you want to give ChatGPT the access to that proprietary information. But AI Assistant does all of this in a very compliant manner, where if you turn on the personalization setting, the AI assistant runs some scheduled searches to learn more about what your data looks like. So not your data, but the shape of your data, the metadata around your data, the names of indexes, source type, field names, even the past search queries. And it uses all of this knowledge to give you very, very personalized responses, which directly translates into queries that are more accurate, require less manual edits, all while honoring the RBAC of the user. So very compliant, safe to use, but you get the power of all of your data. And then just to put the cherry on the top, all of these skills are available to you at no additional cost. Not only are they available to you at no additional cost, Splunk bears the cost of all the GPU inferencing and the infrastructure for you to be able to take advantage of these AI features. So we really, really want you to use it and not have to worry about cost at all. And really excited for you guys to take advantage of this.
And Mohit, maybe I'll just offer another kind of perspective on this. I think anyone who's heard about the AI assistant, maybe been to our different tech talks, so on and so forth, you might have heard us say that it's free and for a limited time. Well, we've done a lot of research, we've given a lot of thought to these particular skills, the ones that you see on the screen, and while we can't predict the future and say that we'll never charge for these things, the decision has been made that that we're going to keep all of these skills free indefinitely. So there's no plan at this point in time to charge for these particular skills. Not that that's a slightly different message than what we've delivered previously. So if you've heard that previous message of free for a limited time, we've amended that message to no current plans to charge for these skills.
Thanks, Jeff. Yeah, we truly believe these skills are what's necessary for you to take full advantage of Splunk Platform. So we want you to use it and not have to worry about the costs. Great. So what can the AI assistant, what are the specific use cases that the AI assistant can do for you guys? So like I said, this has been a GA product for a while, for at least cloud customers. And in that time, we have observed how our customers are using it. And what we've done is we've encapsulated all of those use cases into a Lantern article, which we link to you after this talk. And so these are these different categories of use cases. And not only did we put them in a Lantern article, we've also embedded them as different categories in our suggested prompt. So when you go to the AI assistant, you would see suggested prompts in all of these categories that can basically just get you started on using the AI assistant much faster, tell you what kind of prompts you can type, so you can adjust accordingly and know the full extent of what the AI assistant can do for you. All right. But as I mentioned earlier, we have not stopped. We've been constantly adding new capabilities. And one way, at least I, as the product manager for this product, what I do is I respond to what our customers are saying. So in January, when we sent a survey to our customers, our users, and we asked them, what would you like AI Assistant to be able to do that it doesn't do today? And a loud and resounding ask was, hey, I want this to be able to optimize my searches. We have a lot of users in our organization who are new. They run searches that are expensive. They take a lot of time. And can AI Assistant help these users write more efficient searches? So I'm very happy to announce, as of yesterday, we have a new capability in the AI Assistant called Optimize SPL. And what it allows you to do is you can either paste an existing SPL search, or when you use the right SPL skill to convert your natural language intent to an SPL, we run an extra step to optimize that SPL for you. And again, this is not doing a compile time or like a very deterministic optimization. What we're doing is something even more sophisticated. We're trying to understand the intent of the original search and then apply all the best practices in the context of that intent, as well as the data that's in your environment. For example, if the AI assistant suggests using a T-stats, it will check if the field that's in the T-stats is indexed or not. So it's not just some generic optimization. It's truly contextual, based on your intent optimization. And the result is optimized searches that are functionally equivalent to what you wanted, and will give you almost the same results that you want, but much, much faster. So very excited. This is in preview. If you update to the latest version, you can start using it. And we would love your feedback on this so that we can harden this feature before GAing it. These are some numbers about optimization. So when we did some internal testing on internal reference tags with a lot of searches, we saw that this can reduce the execution time by 40 seconds on average. Sometimes minutes can be shaved off from these searches. And we always compare all of these things to a baseline. And in this case, it was ChatGPT 4.0. And it's outperforming ChatGPT 4.0 in all of these metrics, such as how many searches can be optimized. When the searches are optimized, are they giving the similar results to the original search or not? So really excited for you all to take advantage of this new capability in AI Assistant. Now, I know you guys are technical and you want to get into the weeds of it, what's under the hood. So I'm going to hand it over to Jeff, who will walk you through all of these. And I'll take some questions in the chat in the meantime.
Awesome. Okay. Thanks, Mohit. Yeah. So I think before I, kind of get into the technical architecture, and that's really what we're going to talk about here, I want to just kind of describe to you guys my journey with AI. As I said at the beginning of this introduction, I switched from, kind of a observability, ITSI, IT operations focus a couple of years ago. I made a pivot to AI. And my lame joke is I always say I couldn't spell LLM when I started, AI a couple of years ago. And so a system like ChatGPT or, the AI assistant for SPL, it was magical to me. I didn't understand how it worked. And of course, it's just software, it's just code. And ultimately, when you start to understand how it works, maybe some of the magic of it gets taken away, but you really start to say, oh my gosh, okay, that's how it's actually working under the covers. And so I want to share that with you because I think it's very interesting. And it's going to ultimately and hopefully help, you guys get better results. So this is kind of the architectural diagram of the AI assistant for SPL. We are going to walk through this diagram kind of in great detail. So we're going to go kind of box by box, if you will. And I'm going to really, kind of describe how this whole thing works under the covers. So the first thing I want to kind of explain here is you'll notice kind of the two big boxes. The first box is the box that represents your Splunk environment. So this could be your Splunk cloud instance, or now with our new on-prem support via this concept called Cloud Connected, this could be, your Splunk enterprise instance that you're running in your data center or, BYOL in one of the public clouds. And then we have the second piece of the architecture, which is Splunk Cloud Services. So this is the portion of the infrastructure that we run, we maintain. And so when Mohit talked before about the fact that, you're not bearing the infrastructure cost, you're not absorbing, SVC utilization or compute usage when you're using the assistant, it's because it's all happening inside of Splunk Cloud Services. And so there's multiple different regional instances of Splunk Cloud Services. So if you're using Splunk Cloud, then we're running our services in the same region that your Splunk Cloud is running in. And if you're choosing Cloud Connected, if you're running it on-prem and you're using our Cloud Connected capability, then you're going to choose the regional instance that you want your services to be served out of. So those are kind of the two big pieces of the architecture. One of the questions that we get just from kind of either a compliance or data privacy and security is, okay, well then are you leveraging, third-party AI providers on the back end? Are you sending our data anywhere? And the answer is no. So we actually run the inference within Splunk Cloud Services, and we're not leveraging OpenAI, Gemini, Grok, or anything else. So your data stays within sort of the four walls of Splunk. Okay, so within your Splunk environment, the first thing that you're going to do is you're going to download and install the Splunk AI Assistant for SPL app from Splunk Base, and that's a pretty typical app installation process. And so the user interface, where you're actually putting in your prompt and you're seeing your response, happens within that particular app. So what you do is you go in there and you type in whatever your prompt is. Maybe you say, hey, help me write SPL to find modifications to AWS security groups or something like that, right? And then ultimately, we're going to send that out to Splunk Cloud Services. All of the AI inferencing is going to happen out here. And then the response is going to come streaming back into the app and ultimately into your eyeballs on the screen. And so then let's kind of dig into what's actually happening in the Splunk Cloud Services environment. So how is this thing ultimately being processed and the response being provided back to you? So the magic happens in what we call the retrieval augmented generation pipeline, or RAG pipeline. So RAG is a very, very common architecture for generative AI applications. And so if you rewind the clock a couple of years ago, when LLMs were kind of first emerging onto the scene and people were trying to leverage generative AI to do things like the AI assistant for SPL is doing, one of the things that people realized is, hey, while these LLMs are trained on a huge amount of publicly available data, and because of that, they're extremely smart. The problem is they don't know anything about my data specifically and my domain specifically. And so, it's difficult for a large language model to accurately create SPL for your environment because your index names are different than everybody else's index names, right? And so that's a problem of a LLM. And so then people said, okay, well, we have to go solve that problem. Well, one of the first ways people try to go solve that problem, there's two ways that they tried to do it. They said, well, let's not use an LLM. Let's build our own models. That's extremely expensive, okay? And it requires a lot of CPU or GPU cost. So just plain infrastructure costs to do that. You also have to have a lot of data, and that data has to be really well structured. And so that's not really a viable path. And then so what people said is, well, we can take existing models and we can fine tune them using our data. And again, fine tuning is less costly than training your own model, but it still has a cost. It still requires data, and it's still a relatively complex process, compared to this concept called RAG. So then the next evolution was people created this design paradigm called retrieval augmented generation, or RAG, and that's really what we're going to talk about here. And basically, keeping it short and sweet, you put your prompt in, and then before that prompt gets sent to the LLM to actually get your response back, there's a whole bunch of stuff that gets added into the prompt. So we make sure that we structure the prompt correctly. We add the right information in there in order to guide the LLM to the most accurate result possible. That's what the RAG pipeline does. And we're going to walk through that. So the very first thing that we do is we run your prompt against a set of guardrail checks. I think there was a question that came through on the chat around, what are you doing to ensure data privacy, that our data is treated securely, so on and so forth. I will try to answer that question as I go through the entire architectural diagram. One of the first things we do are these guardrail checks. Now, this is a non-exhaustive list of, some of the guardrail checks that we do, but just give you an idea, we're checking for profanity. We're making sure that users are speaking in a language that is supported by the assistant. We're looking for prompt injection. So this is, a very common concern that people have with regard to, keeping LLMs on target, not hallucinating it, and not disclosing information they shouldn't. And then we're looking for gibberish as well. So if you were to go into the assistant and you were to ask a question that would, in theory, trigger one of those guardrail checks, like I did here, I said, tell me how to become president of the United States. This is what it's going to look like when you fail a guardrail check. It's not going to tell you that you're failing a guardrail check, but you're going to get a response that looks something along the lines of, sorry, can you try rephrasing, change something around? That's our subtle way of indicating that that prompt, has been disallowed for one reason or another. I do want to call your attention to the thumbs up and the thumbs down that you see over here, because our guardrail checks are actually implemented both by some rules-based logic as well as some, AI-based logic. And so it is possible that guardrail checks might accidentally have a false positive trigger, right? And so we want you to provide feedback to us by clicking the thumbs down button, and helping us understand that, hey, it looks like maybe a guardrail check was triggered when it shouldn't have. So we definitely respond to that feedback, and we continuously evolve, modify, and correct and improve our guardrail checks. Okay, so assuming that your check gets through the or your prompt gets through the guardrail checks, which most of them will, the next part is we do this concept called prompt augmentation. This is really where the magic happens. If you are hearing, if you're if you hear people talking about generative AI concepts, you're definitely going to hear them use the word RAG, or retrieval augmented generation. You're also going to hear them use the term vector database. And so I'm sure some of you know what vector databases are, and I'm sure some of you don't. So I want to kind of describe, what does a vector database do and how do we use it during the RAG process in order to provide the right information within the prompt. Basically, what we do is when you provide your prompt, what we have identified a list of somewhere between 30 to 40,000 different SPL queries. As you can imagine, we believe that, we know we are the SPL experts, right? We've seen it all. And so we've collected all of these different SPL queries from all of these different locations. And we've created that, and we've put all those SPL queries into our vector database. And so what we do is, when you put your prompt in there, we are going to augment your prompt. We're going to add information into your prompt for the LLM. We're going to identify the top 5 SPL queries that look related to the prompt that you provided. And I'll explain kind of how we do that here on the next slide. So this is kind of our first way of guiding the LLM towards a more accurate response. So let's imagine that your prompt says, write SPL to find changes made to AWS security groups. So what we do is we tokenize the prompt, which is really breaking this sentence into individual tokens, and then we vectorize those, those tokens in that prompt, right? So vectorizing really just means creating kind of a mathematical array for whatever your prompt is. And then once you have that, you have the ability to execute a search in your vector database for similar results. So the key to vector databases is they allow you to do similarity searches, in this case, text-based similarity. So what we're going to do is we're going to look across those 30,000 different SPL queries in the descriptions that we have for them, and we're going to find descriptions that look similar to the description that you, or whatever your prompt was. And then we know that we take those SPL queries and we add that into the prompt, and we say, we tell the LLM, here are some similar SPL queries that are used to answer similar questions. So use those, consider that as you provide an answer back, is kind of the concept of prompt augmentation. And then, as Mohit described, we're not just using those generic similar SPL queries. When you turn personalization on, if you turn personalization on, because it is an option, we're going to perform that exact same prompt augmentation, but we're going to do it with information that's very, very specific to your environment. We are going to add into the prompt the names of the source types and indexes that are most likely to be the indexes and source types that contain the data that are going to, give you the answer to your question. We look at all of your field names for all those source types, and we actually describe those field names. So we're providing guidance to the LLM on specific field names that it should consider in the response. And then we're actually grabbing SPL queries that you all have run specifically in your environment. And then we're going to further guide the LLM and saying, here are some queries. Here are the top 5 SPL queries that have been run in your environment that are most similar to what's being asked for. And hopefully, and ideally, with all of this information in the prompt, we're going to give you a much more accurate answer than what you would get if we didn't do any of this prompt augmentation. So that's a huge part of the secret sauce of what we do under the covers. Once we do the prompt augmentation, the next thing we do is called prompt engineering. And anybody who has used ChatGPT, you've done prompt engineering in some way, shape, or form. Just as a joke, one time I asked ChatGPT, I started my prompt with, I want you to answer everything. I want you to respond to me in Pig Latin. And of course, it gave me the answer in Pig Latin, right? So that's an example of prompt engineering, silly prompt engineering, but that's really where we're kind of providing the boundaries and the guardrails for the response that we want back. So again, this is a non-exhaustive list of, some of the different prompt engineering that we do behind the scenes before we send it to the LM. So of course we, tell it, hey, you're an intelligent assistant, and you're an expert in Splunk, and so we want you to, provide SPL. That's pretty obvious. We guide it towards breaking down what the prompt was, and kind of pulling the key pieces of information out. And then we do a lot of guidance on, how it should provide responses back, right? So things like, don't use index equals star or source equals star, because we know those aren't good ideas. Tell it to think logically through, so on and so forth, and, present a syntactically correct and clear answer. And all of this is really instrumental in making sure that we get back the most accurate response, and we also get back a very consistent response that we can surface up to you in the UI. Okay, and then once we do all that, that's ultimately when we send that fully engineered prompt to the LLM to get the response back. So this is really what the whole process looks like. You're going to put in your really simple, short and sweet user prompt. It goes through our whole RAG pipeline, and it ultimately creates this fully engineered prompt that has instructions, context, output formatting, so on and so forth. That's what we send to the LLM, and then the LLM then uses that to provide the response back, and we stream that back to the user interface, and that's really what you're looking at. And that is the whole process. It's how it works. So with that being said, one of the questions we get asked a lot is, okay, which LLM are you using? And I'm going to talk a little bit more about this in the quality and accuracy part of this. But the reality is there's multiple different LLMs that are out there, and we have identified which LLM kind of provides the best results possible. And that's the LLM that we use. And I'm going to talk a little bit more about that. What does our quality and accuracy process look like here in just a little bit? Okay, so then let's talk about this is kind of the configuration side of things. I want to walk through how your data gets to the vector database. We'll start with customer metadata first. So as Mohit said, this is really used during the personalization, process. So we're not collecting the information in your environment, but we are collecting the metadata. Index names, source type names, field names, previous SPL searches. If you choose to turn on that metadata sharing, what it basically does is it turns on a couple of saved searches and modular inputs, and those run regularly, and they ship the data off to the vector database. So you would do this through the settings page. It's just one simple toggle to turn personalization on, and that's what's sharing that metadata. And then if and when you turn that on, here's kind of a little bit about the searches and how that data is collected. So, one, kind of key point to note here is the scope is that this is environment wide. So you're either going to turn personalization on or off for all of the results across the entire environment. It's not a per person, per role concept. And then, in terms of collecting index names, source type names, and field names, our collection mechanism is a modular input. This is the name of the modular input. It runs every 12 hours. And then from a configuration perspective, there's one macro that would allow you to kind of include or exclude various indexes. So if there's certain indexes that you don't want to participate in the metadata sharing and personalization, you can modify this macro to kind of restrict that. And then in terms of collecting the historical SPL searches, we have a saved search called Splunk AI Assistant for SPL, cloud version search logs that runs every day at midnight, and there's no configuration for that. The second, optional thing that you can turn on is the usage data. And so this actually allows us to understand, who is using the assistant and how are they using it. And effectively that information gets sent to Splunk telemetry. So in the settings page, if you turn on this usage data sharing, that is going to send a couple of key pieces of information to us. Again, we use that to understand adoption, usage, quality. So our quality, assurance process is tightly tied to looking at the data that is shared with this usage setting. Similarly, its scope is enabled or disabled for the entire environment, and then similarly, it has save searches to send the data off. So there's three different save searches, one for end user usage telemetry, one for capturing when people click open and search, and then the last one for feedback, thumbs up, thumbs down. I won't read all of these, but for posterity, you can check these and you can see these searches present in your environment when you install the app. Okay, so that's covers kind of the architectural side of it. Now what I want to do is I want to talk about the quality and the accuracy side of it, because there's a lot of questions that get asked around this. And the way the question usually starts is like, well, is it better than ChatGPT, or is it better than Copilot? Or sometimes people tell us, hey, I tried Copilot and I got a more accurate answer. I tried ChatGPT and I got a more accurate answer. So, so obviously we believe that the AI assistant for SPL should produce the most accurate results. And we have a pretty rigorous process that we go through to try to ensure that we are, in fact, the best. And it doesn't mean that on a kind of a one-off case-by-case basis, you're not going to get better results from one thing versus another. That's always going to be the case. But we're trying to look at this in very, in aggregate fashion. Okay, so here's kind of how we approach quality and accuracy of the AI assistant. There's three major things that we do. The first one is that we actively benchmark ourselves against ChatGPT, ensuring that our results are more accurate. I'm going to walk through how we do that. We also have a ton of configuration tuning that can be done within the model and all the parameters in the RAG. And so I'll talk through that as well. And then, lastly, based on however the system's produced and whatever responses we get back, we're continuously, performing a retrospective quality assessment, and we're improving the software based on that. Okay, so let's kind of get into the benchmark comparison with ChatGPT. So the way that we do that is we start with this reference data set, and you can really think of this as a prompt and an expected SPL. So if we applied this prompt, here is a piece of SPL that's a reasonably good answer for that particular prompt. That's what the reference data set looks like. So we take every prompt in the reference data set and we run that through GPT-4o, and we also run it through the AI assistant for SPL. Now, in full transparency, when we run it through GPT-4o, we're just putting in the user prompt exactly the same way that you would just put in the prompt if you were in ChatGPT. But when we run it through the AI assistant, we're actually running the fully engineered prompt through that includes all the prompt engineering and all of the RAG, okay? And so this is really the reason why it's better. But again, if you're not doing all of that RAG and prompt engineering on the fly in your ChatGPT, then that LLM just doesn't have access and understanding of that information. Okay, so we run it through those two different systems and we ultimately come up with SPL. So we look at the GPT-4o SPL, we look at the AI assistant SPL, and then we look at the expected SPL and we just compare the results. Does GPT-4o's SPL look more accurate than than the AI assistant for SPL's SPL versus what we would expect it to have, right? So that's exactly how the process works. And so here is a kind of a breakdown of all of those reference data sets running against GPT-4o, running against the AI assistant for SPL when personalization is off and when personalization is on. And I'm going to walk through what blue and rouge and field precisions and all that mean here in a second. But you can see that in all cases, the AI assistant for SPL is producing as good or better of a result than GPT-4o. And sometimes personalization is better, sometimes it's worse. But this is the type of data that our data scientists are consistently and continuously looking at to ensure that we're getting the best results possible. Okay, so let's walk through some of these example metrics of comparison. Again, these are not all the metrics of comparison, but there's some pretty important ones that we look at. So we look at blue score, rouge score, various field precisions, and then parsability percentage. So blue score and rouge score is really just saying like, how similar is the resulting SPL to our expected SPL? So blue and rouge are slightly different, but generally speaking, we're trying to say like, does the SPL that was produced look pretty similar to what we'd expect it to look like? Index, source type, and field precisions. This is really saying, like, how often does the resulting SPL contain the index, source types, and field names that we see in our reference SPL data set? A higher, occurrence of those values, the more accurate the SPL is going to look. And then finally, parsability percentage. This is saying, like, does the resulting SPL actually pass through the SPL parser without any errors? And so if you just look at some real world examples of this from our reference data set, we have one, we say, show me a summary of the fields from the first 5,000 events in the server container logs. ChatGPT responds one way, Saya responds another way. Why is Saya better in this particular case? Well, we got a fully executable query based on results personalization. Okay, so our index was substituted correctly here, and then this field runs. So this is a good SPL query, but it's not specific to your environment. Next example, show me the top 20 actions recorded in the audit trail. In this particular case, we got really, both of them are work, but our response here is a little more concise, a little more readable, so maybe a little more accurate. And then finally, retrieve information about all data inputs from a Splunk instance, blah, blah, blah. ChatGPT responded with this pipe input status, which is not a command. AI system for SPL returned with a REST command here. Okay, so not parsable SPL coming from GPT-4o versus a parsable and accurate SPL coming from the AI system. Okay, so that's kind of covers the benchmarking against ChatGPT. So let's talk about this model and parameter configuration tuning. So if you go back to this RAG pipeline, the reality is that within the RAG pipeline, there's actually a lot of configuration tuning. There's a lot of software that we wrote, that we control in that pipeline, and therefore there's a lot of tuning that can be done. And we obviously have done extensive analysis against that tuning. Okay, so what's some of the tuning? First is, what's the best model to use, right? So we talked a little bit about that. So there's a bunch of different models that are out there. We've looked and we've identified the best model. What is the best template? Like what should that prompt engineering template look like in order to produce the most accurate results? Then again, with this RAG, specifically when we're going to the vector database and we're grabbing that information, there's a lot of tuning and configuration parameters around that. And then ultimately context windows. So context windows, drive how the assistant responds to follow-up prompts. It's kind of the balance between a more accurate result versus a response that's coming back more quickly, and and balancing again cost versus accuracy and performance and all that. So there's a lot of configuration parameter tuning. So going back to this model identification, as I said multiple times now, there's a lot of LLMs that are out there. And so what we've done is we looked at, multiple different LLMs. So you think about it, they're all trained on different data sets, right? So maybe some of them were trained on more Splunk versus less Splunk, right? Maybe some of them were trained on more code versus less code. So you need to try multiple different candidate LLMs in order to identify the one that, consistently produces the best results for you. And that's what we've done. We take all these candidate LLMs, we run them through our reference data set, we look at all those blue and rouge scores, and we say, okay, this is the model that is consistently performing the best for us, and that's the model that we use in the AI assistant for SPL. And then when you jump into kind of the RAG implementation and configuration, there's a couple of key values that we look at. There's called top K and threshold. So top K, just as an example here, let's look at source types and indexes. We pull the top 7 most appropriate source types related to your prompt. Why 7? Why not 10? Why not 5? Well, we tested all that. Okay, we tested all those different permutations, and we decided that the top 7 gives you the best result. Similarly, threshold says how similar must the item in the vector database be to the prompt before we pull it or don't pull it, right? Does it need to be 95% similar? Does it need to be 50% similar? Does it need to be 80% similar, right? So again, how did we land on 80% similarity? We tested a whole bunch of different configuration parameters, okay? And then we're doing that individually across all of these different, we're doing it differently. We've evaluated differently for similar SPLs versus source types and indexes versus field names versus historical SPL queries. So our data scientists have done a tremendous amount of, kind of matrixing all of the different configuration parameters to identify what gives us the most accurate result. And this is kind of what it looks like. If we're going to deploy a new, configuration to basically push a new instance of the AI assistant to prod, we're running all those, kind of those tests, all those different configuration parameters, and we're seeing which one behaves on average, which one appears to give us the best result compared to what we had previously. And that's the configuration that we roll with. So as you can imagine, there's a lot of, different ways to kind of tune that, and we've ideally tuned it. And then finally, and let's be clear, going to kind of our retrospective quality analysis, we know that not every query is going to produce perfect SPL. We want it to, but it's not. And so to identify where we're failing and how we're failing, we have this continuous quality review and improvement process. And I'll walk through that really quick. So the foundation of this is the data collection from telemetry. So, obviously not every customer is comfortable with sharing that, but, if you do share that, understand that that data is critical for our quality analysis. So we collect all that data, primarily the telemetry. We do a qualitative and quantitative review. We classify failure results. So if something is not right, why is it not right? And then that drives prioritized improvements. So looking at kind of our qualitative results, we're looking at for every prompt that you put in and the corresponding result that we get back, how many of them are parsable? What is the context length that we're using? How many times do we trigger guardrail checks? How many times do the users appear to be dissatisfied with the response? So we're looking at and tracking those kind of KPIs over time, making sure that we're hopefully making them better, but certainly not making them worse. And then we identify kind of a target list of responses, so prompts and responses to actually go, kind of spot check, if you will. So any guardrail checks get added into the list. We want to look at those. Anytime where people are doing conversation, like multi-turn. So you're asking a prompt and you're following up and you're following up and you're following up. That can be a strong indication of something going really good. It could be a strong indication of something going really poorly. So we want to look at some of those conversationals. Obviously, if you're providing feedback, we're looking at any thumbs down feedback. We look for implicit dissatisfaction. So, sometimes when I'm in ChatGPT, I say, wrong, or something like that. So there's kind of telltale signs within the prompts that would make it look like you are a dissatisfied user. So we spot check those, and then we do some random sampling. So we kind of come up with, for our real actual production data, we come up with this group of prompts and responses that we're going to kind of go and perform some quality analysis against. And then, like I said, once we have that group of prompts and responses, we categorize it. So I won't read all of these, but, like a really good example is unsupported features. So this is a case where you might have asked the assistant to do something that it's incapable of doing. And so, that's why it didn't do it, right? It's because we didn't code it to do that. So, maybe you asked it to optimize an SPL query and it's not designed to do that. So that would be flagged as an unsupported feature. So we use that to drive, in part, what we want to do next. Domain knowledge gaps. So like, for instance, maybe we got a lookup wrong or something, and that's because we're not incorporating your lookup names into into the RAG and into the engineered prompt. So we say, like, if we had that information, we probably could have produced a more accurate response. So anyway, we kind of classify the different failures across different classifications. And then as you can imagine, each different type of classification failure is going to drive a software change that we believe is going to make it better, right? So if we see a particular guardrail check that is triggering too many false positives, then we're going to go evaluate that guardrail logic and try to improve it, and test to ensure that our false positive rates are dropping, right? So that'd be a good example of, and we've done that before. So that's kind of how we approach the quality and accuracy part. And so with that being said, we're right on time. Mohit said, hold your breath for the big surprise at the end. And now we're at that point in time. I am really, really, really excited to announce that we have created. So we're gonna exit the land of AI Assistant for SPL, and we're gonna enter into a new land of agentic AI. Okay, and so we have just released the Splunk MCP server, which is really designed to allow you and your organization to begin building your own agentic AI workflows and to actually gain access to the data that's in Splunk in your AI applications. So for those of you that maybe have not, or maybe you've heard the term agentic AI, but you don't know exactly what it does, what agentic AI is it's an LLM that's going to take the user's prompt, and it's not just going to barf out a response. It's going to actually look at the prompt, and it's going to then cross-reference what are the tools, what are the skills, what are the capabilities that I have access to in order to better answer that prompt. And then it's going to decide, okay, I'm going to call this skill first, and then I'm going to call that skill second, and then I'm going to call that skill third, and then maybe I synthesize the response from all those, and then that's what I send back to the user, right? So that's really kind of a simple overview of how agentic AI works. And so MCP is a emerging protocol. Stands for Model Context Protocol. It's an emerging standard for generative AI, for agentic AI applications that allows access to data in Splunk. So this is now available for Splunk Cloud customers in a limited availability. And just to kind of give you an idea of what this looks like.
Jump in, Jeff, quickly, that the MCP server as of today allows you access to a lot of foundational capabilities in Splunk Platform. But in the coming releases, we will add all of the capabilities from the AI assistant that we talked about in this presentation. All of them will also be available through our MCP server. So your agentic applications can take full advantage of the same capabilities that our AI assistant has.
Yeah, awesome. And so I'll say this too, like if you're hearing MCP for the first time, or you heard about it, you don't know what it is, just do a quick Google search. There's great YouTube videos that are out there that describe what it is and how it works. There's obviously documents and articles. So there's plenty of information online to go learn more. But this is a really simple and quick example of using Splunk MCP inside of Claude Desktop. So I just put in what data do I have indexed into Splunk, and what you can see is Claude is actually looking at the different skills. It's calling get Splunk info first, and it's calling get indexes, and then it's calling get metadata, and it's using all of those responses and ultimately synthesizing a response back. And what can really make MCP powerful, or what can really make these LLMs and agentic AI powerful, is when you have multiple MCP servers plugged together, right? So you can imagine maybe there's an MCP server for Splunk, maybe there's an MCP server for Confluence. And so the LLM could read a runbook from Confluence and actually follow that runbook and call into Splunk to get data, right? To actually, execute a full-on investigation in a agentic and autonomous fashion. It sounds magical. It sounds almost impossible, but this is actually the technology that's emerging. It's really, really cool. And so we're going to talk. We're going to unveil some really cool stuff. We're going to talk about the capabilities and the power of MCP at .conf this year. This is one conf, guys, you do not want to miss. So try to get out there. It's in Boston, September 8th through the 11th. I will be there. Mohit will be there, and we really hope to see you there. And with that, we have a few minutes left for Q&A. So I'll go ahead and pause. And if anybody has questions, or Mohit, if we got questions through the Q&A that we want to ask out loud, we can do that here.
Let's do that. And I've been answering the question in the chat. I think one question which was around, will these AI assistant capabilities be available through APIs? So as I mentioned, not only as APIs, but they will also be available in the MCP server very shortly. So yeah, stay tuned for that. Let's see. I think there was a question around how can customers bring their own, or admins bring their own prompts and whatnot, and do more organization. There's a couple of ways to do it. One is, as Jeff mentioned, if you go down the MCP server route, then you could have your own prompts in your own, let's say, Confluence page, and you can connect your MCP. So there's an MCP router where you can bring it from outside of Splunk. We do have an item on our roadmap to have some kind of a prompt library. So it's something that's being in the works. I do not have the timeline right now. Jeff, would you like to add anything to that?
No, I think I agree. We have the default prompts that are present in the product, but certainly we've heard the request before, and we're considering, extending those default prompts to allow for customization of custom prompts and maybe even custom prompt engineering. So those are things we've heard before and we're considering. Okay, I will just advance to the next slide and we'll hang out for a couple more minutes. We'll let you all drop if you want to, but as usual, there's plenty of opportunity to continue the conversation on the Splunk community. That's community.splunk.com. We continuously host office hours, so you can talk to technical experts, ask questions. Please do that. Of course, Splunk Docs and a Lantern to get information and how to. And then if you haven't done it, ideas.splunk.com. This is the way for you to kind of request enhancements to solutions. We have an area around AI. Mohit actively reviews those. Submit ideas, and we're continuously watching those. And so we'll hang out for a few more minutes to answer any more questions that come in. But at this point in time, thank you very much, and you all are free to drop.